I'm back. And the second video on limits. Where am I? I've already completed one. Yes. This is my second video on limits. And it's going to be called...
Limite la deuxième partie.
Can you repeat that for me, please?
Limite la deuxième partie.
Thank you very much. All right. So, at the very beginning of this section, we're going to be, if you notice, all the little rules I have here are based on, well, most of them anyway, are based on the use of trig functions. All of these can be proven, but the purpose of this course is not to prove these expressions, but to use them to our advantage. For example, let's start with the first one. The limit as theta approaches 0 of sine theta over theta. If you were to just plug theta equals 0 into both numerator and denominator, you'll get 0 on top and 0 on the bottom. However, it can be proven that the limit as theta approaches 0 of sine theta over theta gives me 1. Now, theta itself doesn't have to be a simple angle. It could be, you can have a multiple angle in there as long as the multiple angle repeats itself in the denominator. If you look on the right, we have a similar expression that says the limit as theta approaches 0 of sine n theta upon n theta. Once you have n theta in the numerator, you must have the same n theta in the denominator as well, there and there. So that limit, the limit as theta approaches 0 of sine n theta over n theta, that's also 1. And then there are some other expressions. I'll read them all out, and then we'll use them to our advantage. What we'll do, whatever expressions we're given to find the limits for, we'll try to massage them or reconfigure them in a way that each part looks like one of these expressions. All right, the second one says that the limit as theta approaches 0 of cos theta minus 1 upon theta. That gives us 0. Right? The one to the right of that says you're simply replacing theta with n theta. So the limit as theta approaches 0 of cos n theta minus 1 upon n theta. That's also 0. Next case, the limit as theta approaches 0 of 1 upon cos theta. That's 1. The limit as theta approaches 0 of 1 upon cos n theta. That's the expression to the right. That's also 1. The limit as theta approaches 0 of just sine theta is 0. And the limit as theta approaches 0 of sine n theta. That's 0 as well. There, just 0. And then the last one, excuse me, oh my God. The limit as theta approaches 0 of, the limit as x approaches infinity of 1 plus 1 upon x all to the power x, that's 0. All right, let's see how well we can apply all of those, I'll call them rules as such, and use them to our advantage. My first example has the limit as theta approaches 0 of sine 5 theta upon 2 theta. Well, obviously, if you look at the expression, the closest thing that matches it is this expression to the right here, over here, all the way over there. But I must have, if I have 5 theta on top, I can't interfere with that 5 in the 5 theta, which means I must replace the 2 theta somehow with a 5 theta. How can I do that? Well, that's not so difficult, because what I'll do, I'll massage it as follows. This is the same as the limit as theta approaches 0 of sine 5 theta. What time did I start this? I started this at 2 o'clock roughly. Time myself here, and this is 2. Give me a minute, let me gather my fundamentals here. 2 p.m. Yes. Of sine 5 theta upon 2 theta. But then what I'll do this little trick. I'll multiply top and bottom by 5. I haven't changed anything, have I? I have not changed anything. Multiplying top and bottom by 5 is just like multiplying by 1, which doesn't change the expression. However, what I'll do, I'll remove the 5 from the numerator and the 2 from the denominator. Pull it outside of the limit. You remember from the first set of rules, the laws of limits. The limit as theta approaches 0 of some constant times a function of theta, you're allowed to pull the constant outside of the limit. So that's exactly what I'm going to do here. But I'm going to pull this 5, this guy, and that 2. What will be left inside? But when I do that, this becomes now the limit. Sorry. This becomes 5 halves, which comes outside, times the limit as theta approaches 0 of, and then I'll have what's left inside, sine 5 theta. And on the bottom, the 5 times theta will also be 5 theta. Nice little trick. Okay, this entire part here, my handwriting is going to the dogs here, man. Theta, there. Okay, this entire portion there, according to this rule up here, right? That's 1. So the limit as theta approaches 0 sine 5 theta upon 5 theta. That's 1. So therefore the result is 5 halves times 1, which is just 5 halves. If I were to conclude, I write the limit as theta approaches 0 of sine of 5 theta upon 2 theta is equal to 5 halves. Okay, that's the method of approach to solving one of these. There. Okay, let's try the next one. Let me separate them. My next example is this one. The limit as theta approaches 0 of cos 3 theta minus 1 over 5 theta. Well, I would like the 5, I said that should have been x, right? Let me change everything to theta, sorry. Cos 3 theta and 5 theta. You can't have theta approaching and then the variable is x. There. I would like that 5 theta in the bottom to be replaced with 3 theta. Right? Remember, I can't remove the 3 from the cos 3 theta. So I might as well try to remove the 5 from the 5 theta in the denominator. So I'll do something similar to what I did above. This is the limit as theta approaches 0 of cos 3 theta minus 1 upon 5 theta times 3 upon 3. And guess what I'll do? I'll remove the 3 from the numerator and the 5 from the denominator. So this becomes, and pull it clean outside of the limit, this becomes 3/5 times the limit as theta approaches 0. And what's left inside? Cos 3 theta minus 1. By the way, maybe I should put this in a bracket. I should. Yes, there. Right? The 3 from the numerator, the 5 from the denominator comes out. What's left inside? On the denominator, I just have 3 theta. Well, what does that look like? That looks very, very similar to this guy. Cos n, the limit as theta approaches 0, cos n theta minus 1 upon n theta. And what's that value? That's 0. Okay, so this is 3/5 times 0, which is 0. What's my conclusion? The limit as theta approaches 0 of cos 3 theta minus 1 upon 5 theta is 0. Excuse me there. Let's try that again. One more time. There we go. All right, let's try the next one. This is an interesting one, isn't it? Yes. Let me pull it up a little bit. I need all that space on top there. Voila. The limit is theta approaches 0 of sine 2 theta divided by sine of 9 theta. Well, I don't have any of the rules in here for that. I have a rule for sine theta upon theta, or sine n theta upon n theta. But I don't have a rule for sine of one multiple angle divided by the sine of another multiple angle. So in this one, I'll apply another trick. It's not really a trick, it's just mathematical sleight of hand. But it's legit. This is equal to the limit. I can't write anymore to save my life. Is equal to the limit as theta approaches 0 of, okay, watch the magic, sine 2 theta upon theta divided by, I need a bigger bracket here, all divided by sine 9 theta upon theta. What did I do there? I divided both numerator and denominator by theta. That's very much legitimate. If I upturn and multiply, theta goes on top, theta in the bottom, they'll cancel back out. I still get back sine 2 theta upon sine 9 theta. So nothing earth-shattering there. And then I'm going to use one of the laws of limits that says the limit of a quotient is the quotient of the limit. So the limit of a quotient is the quotient of the limits. That's right. In other words, limits distribute over division. That's the short way to say that. So I'll now rewrite this as, should I rewrite it now? Yeah. This becomes the limit as theta approaches 0 of the numerator portion, which is sine 2 theta upon theta, all divided by the limit as theta approaches 0 of sine 9 theta upon theta. Oh, you like them apples? Looks kind of good. And then, but if you notice in the numerator, I have 2 theta as a multiple angle for the theta, but I only have theta in the bottom. But we should know how to deal with that now, right? Because all I need to do is multiply top and bottom by 2 and factor out the numerator 2. Same thing in the denominator portion. Multiply top and bottom by 9 and factor out 9 from the numerator. So let's do that right now. This becomes the limit as theta approaches 0 of sine 2 theta upon theta times 2 over 2. Right? I ain't changing that, nothing there really. Divided by the limit as theta approaches 0 of sine 9 theta upon theta times 9 upon 9. This numerator 2 will be factored out, and this denominator 2 will slide together with that theta there. Similarly here, this numerator 9 will be factored out, and this denominator 9 will pull it together with that theta. Let me get my eraser going here. Voila. So let's do that. This now becomes the 2 times the limit as theta approaches 0 of sine 2 theta upon 2 theta, all divided by 9 times the limit as theta approaches 0 of sine 9 theta upon 9 theta, which gives me, so this whole portion, all of this stuff here, that's 1. And this whole portion there, that's 1. So the result is 2 times 1 over 9 times 1, which is 2/9. Summary. Let me give myself a little space here. If I were to summarize that, I will say sine 2 theta, limit. The limit as theta approaches 0 of sine 2 theta divided by sine of 9 theta is equal to 2/9. Now I know it's kind of tempting. If you look at that expression there, it ends up being the 2 that's a multiple angle for the theta in the numerator, and divided by the 9, which is the multiple angle for theta in the denominator. You can't just write the 2/9. You have to prove it, and that's what we just did. Because technically, if you plug in directly theta equals 0 into the numerator, you'll get sine 0 upon sine 0, which is 0 upon 0, which is undefined. So what we've gone through here is the actual proof that you end up with 2/9. So don't forget how to get that done. Okay, that's the end of that one. Let's try another example. Limit as theta approaches 0 of tan phi. I put a little note for myself on the right there to remind myself how to get this one done. So I'll remove the note and then do it over from scratch. Delete. There. Limit as theta approaches 0 of tan 5 theta upon theta. If you go back up to our rules, we ain't got a rule. We don't have a rule for tan. So somehow we have to massage this thing in such a way that we get rid of the tan. And that's probably the easiest thing to do, because one of the first identities we learned in our trigonometry is that the tan function is equivalent to the sine function over the cos function. So this becomes the limit as theta approaches 0. There should have been a 0 there. As theta approaches 0 of sine 5 theta upon cos 5 theta times 1 over theta. Right. Remember tan, technically this part could have been written as tan 5 theta times 1 over theta, like that. I could have separated it right there. Maybe I should do it that way. Give me a second here. Yeah, let me actually show that. Go away, go away, go away. All right, yes. All right, so this becomes the limit as theta approaches 0 of tan 5 theta times 1 upon theta, right? And then I'm going to split the tan 5 theta into sine 5 theta over cos 5 theta. So this now becomes the limit as theta approaches 0, not theta, of sine 5 theta upon cos 5 theta times 1 upon theta, like so. Okay, is there anything we can do here to invoke any one of the rules we've learned before? Sine theta over theta, that looks like it's going to come into play, and 1 over cos theta, that looks like it's going to come into play. Because what we're going to do now is to exchange the theta and the cos 5 theta. And this becomes the limit as theta approaches 0 of sine 5 theta upon theta times 1 upon cos theta. The limit operation distributes over multiplication, so we can split this into two separate limits. This becomes the limit as theta approaches 0 of sine 5 theta upon theta, but then we know what to do with this already. So why don't we just multiply top and bottom by 5 one time? Times the limit as theta approaches 0 of the 1 upon cos theta. Like so. One more line before I write my conclusion. This becomes, I'll pull out the numerator 5 times the limit as theta approaches 0 of, and now inside now I have sine 5 theta upon 5 theta times the limit as theta approaches 0 of 1 upon cos theta. And according to the rules from above, let me double check myself. Sine n theta, where n theta, that'll give me 1, and the limit as theta approaches 0, 1 upon cos theta, that's also 1. So what do we have? This becomes 5 times 1 times 1. Right? This whole portion is 1. This whole portion there is 1 as well. What's the result there? 5. Summarizing, the limit as theta approaches 0 of tan 5 theta upon theta is 5. And that's all she wrote for this one. So far, so good, right? I got one more example before I give you a worksheet. Because this worksheet, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 problems, and several of them are centered around the same set of ideas that we were just working on here. Give me a minute, let me tidy up here. Okay. The limit as theta approaches 0 of tan theta minus 2 theta upon sine 3 theta over 7 theta. Interesting. Yes, I made myself a note for this one as well. Let me remove this note because I pretty much know how to handle it. There. Give myself a little more space. Okay. Now, remember, we don't have a limit for tan, so we got to change that tan to sine over cos. The sine 3 theta, somehow we got to get theta, sine 3 theta over 3 theta in that case. So it appears as if we got to divide this sine 3 theta over 3 theta and break up the tan into sine over cos. So I'm going to start by getting my theta underneath the sine 3 theta. So I'm going to divide both numerator and denominator by theta. And I'll say that in words first. Divide both numerator and denominator by theta. There. If I did that, this becomes the limit as theta approaches 0 of tan theta over theta. That means each piece will be divided by theta, right? Minus 2 theta over theta, all upon, I need a bigger bracket here, all upon sine 3 theta over theta minus 7 theta over theta. Yep, if I divide both numerator and denominator by the same thing, I haven't changed anything. If I multiply numerator and denominator by the same thing, I haven't changed anything. There. Okay. Now I have several different parts to work on. This becomes the limit as theta approaches 0 of, I'll write the tan theta over theta as tan theta times 1 over theta, like that, minus 2 theta over theta is just 2, all divided by sine 3 theta over 3 theta, over theta, sorry. I didn't get the 3 theta in there yet. And then minus 7 theta over 7 theta over theta is just 7. Tan now can be written as sine over cos. So this becomes the limit as theta approaches 0 of sine theta over cos theta times 1 over theta minus 2, all upon, keep making this bracket too small, all upon sine 3 theta upon theta minus 7. Okay. Another thing I have left to do here is to switch the theta and the cos theta. Let me do it right here. This becomes the limit as theta approaches 0 of sine theta upon theta, that's fine, times 1 upon cos theta minus 2, all upon let's try that again. There, all upon sine 3 theta upon theta minus 7. Limits distribute over multiplication, limits distribute over division, limits distribute over addition, limits distribute over subtraction, limits distribute over addition, subtraction, multiplication, division. So I'm going to split this up into a bunch of different limits. Y'all ready? This is equal to the limit as theta approaches 0 of sine theta upon theta times the limit as theta approaches 0 of 1 upon cos theta minus the limit as theta approaches 0 of 2, all upon, mercy, all upon the limit as theta approaches 0. And here's what, I'm going to go back here and save myself a line. I'm going to massage this piece right here and multiply and divide by 3. Right there. Right? And that will save me an extra line that I have to work with here. And then when I'm doing this part of the limit now, I'll pull out the numerator 3 and leave the rest of the expression as sine 3 theta over 3 theta. Get it? So 3 comes out times limit as theta approaches 0, 0, 0. Jeez. As theta approaches 0 of sine 3 theta upon 3 theta. And then minus the limits as theta approaches 0 of 7. Mercy. All right, let me see if I can get all these different limits. 1 upon cos theta, is that, I think that's 1 as well, right? 1 upon cos, 1 upon cos. 1 upon cos is 1. All right, so there we go. This becomes the first limit. The limit of theta approaches 0 sine theta over theta, that's 1. Times the limit of theta approaches 0, 1 upon cos theta, that's also 1. Minus the limit of theta approaches 0 of 2. 2 is a constant. The limit as theta approaches anything of a constant is that constant. So that would be 2. Now this entire thing is 0? No, sorry. 1 minus 2. All upon and in my denominator I have 3 times limit as theta approaches 0 sine 3 theta upon 3 theta, that's 1. And the limit as theta approaches 0 of 7, that's 7. What do we have here? 1 minus 2 upon 3 minus 7. 1 minus 2, that's minus 1. 3 minus 7, that's minus 4, I think. 4, 5, 6, 7. Okay. So this is a quarter. At the end of all that good work, what do I end up with? Let me summarize. Give myself a little space. And I'll actually copy this. Voila. Insert, paste that limit. So to summarize that, yes, that result is 1/4. Again, y'all please double check my arithmetic. But I think I'm okay. And there, that's that limit. And those are the examples that I wanted to show in this tutorial or this video. And now the only thing left for you to do would be the homework problem. Make sure you understand exactly all the concepts that I applied up here in all the different examples. Each one tested something a bit different, but they all, at the end of the day, I had to go back to this set of rules right here and use them in some way. So whatever the function looked like, I had to massage it until each part looked like one of those. All right. The homework is from our regular text. Nothing has changed. I'm using the regular textbook, exercise 12B on page 362, and the numbers are as shown there. 22, 24, 26, 28, 29, 30, 34, 35. This is a good workout. You should be in good shape after you're finished with that worksheet. And this video is pretty quickly done. I like. Now there is one more video on limits, and that one is very technical. So it might take quite a bit longer than this one. I have to slow down and explain certain things about discontinuities and when is a function continuous, when does the limit exist, and so on and so forth. Some very, very technical things. So these first two videos was more or less plug and chug, and we arranged things a little bit using some algebra and some trigonometry. That third one, you gotta sit down on it to make sure you really understand it. And I'm gonna do it actually in about half an hour. I'm gonna run that one through as well. All right, that's it for now. I'm out.